The sky. For millennia, it was a concept of open, free, and infinite space, a canvas for poets and a highway for explorers. But in the cold, calculating minds of modern military strategists, the sky is the ultimate vulnerability. It is the three-dimensional chessboard where wars are won or lost before the first infantryman even boots the ground. Whoever controls the airspace dictates the flow of battle, holding the power of life and death over the theater of war. The doctrine is simple. Deny the enemy the sky, and you break their capacity to fight. And to enforce this doctrine of absolute denial, the Russian defense industry engineered a mechanical Leviathan, a system not just designed to shoot down aircraft, but to completely lock down vast swaths of the atmosphere. Welcome to the definitive breakdown of the S-400 Triumph, NATO reporting name SA-21 Growler. This is the Steel Symphony of the Sky. To truly understand the terror the S-400 instills in opposing air forces, we must first look backward. The genesis of this monster lies deep within the paranoid corridors of the Cold War. In the decades following the Second World War, the Soviet Union faced an existential threat from the sky. High-altitude American nuclear bombers like the B-52 Stratofortress, and later, the SR-71 Blackbird spy plane. The sheer vastness of the Soviet landmass made it impossible to defend with interceptor fighter jets alone. They needed a shield. This necessity birthed a unique military philosophy that remains intact today: the obsession with ground-based, highly mobile, long-range air defense. While Western powers invested heavily in achieving air superiority through advanced fighter jets, putting their faith in the F-15S and F-22S to clear the skies, Russian military doctrine focused on building an impenetrable umbrella from the ground up. It started with the S-75 Dvina, the system that famously shot down Francis Gary Power's U-2 spy plane in 1960. It evolved into the legendary S-300 series, a system that haunted Western planners for decades. But as the 21st century dawned, the threat matrix changed. The enemy was no longer just high-flying bombers. It was stealth fighters like the F-35, hypersonic cruise missiles, precision-guided munitions, and swarms of low-flying unmanned aerial vehicles. The S-300 was a masterpiece of its time, but the modern battlespace required something faster, smarter, and with a reach that defied the curvature of the Earth. It required the Triumph. Welcome to the beating heart of the Almazante Defense Industrial Complex. This is where the theoretical mathematics of air defense become a physical, terrifying reality. What you are witnessing is not a standard automotive assembly line. It is a colossal, hyper-sterile laboratory where heavy industrial mechanics violently collide with nanoscale electronic engineering. Look at the massive diamond-tipped rotary cutters inside the 5-axis CNC milling machines. They are shaving microscopic, gleaming ribbons of aerospace-grade titanium and aluminum alloy to form the structural ribs of the missile launch tubes. At hypersonic intercept speeds exceeding Mach 6, the aerodynamic stress on a missile airframe is unimaginable. A structural flaw the size of a human hair, a weld that is off by a fraction of a millimeter, can cause a multi-ton interceptor to violently tear itself apart from atmospheric friction before it ever reaches its target. Everything here, operating under the cold, calculating gaze of chief engineers and brilliant aerodynamicists, must achieve absolute, uncompromising perfection. The margin for error is exactly zero. But the true terror of the S-400 does not just lie in its raw, kinetic muscle. Its true power resides in its electronic brain, or rather, its multi-layered network of brains. The S-400 is not a single vehicle. It is a complex, networked organism of highly specialized machines working in absolute synchronization. The eyes of this organism belong to a trio of terrifyingly powerful radar systems. First is the 91 N6E panoramic radar, designated by NATO as the Big Bird. This massive, double-faced radar spins tirelessly, broadcasting S-band frequency waves to detect ballistic missiles and aerodynamic targets up to 600 kilometers away. It is the early warning sentinel, scanning the horizon for the slightest atmospheric disturbance. Second is the 96L6E, the cheeseboard radar. This operates in the C-band and is designed to detect targets at all altitudes, specializing in picking up low-flying cruise missiles and stealth aircraft, trying to hug the terrain to avoid detection. But the most lethal component of this sensory network is the 92 N6E active electronically scanned array engagement radar. NATO knows it by a much more ominous and fitting name: the Gravestone. Inside the absolute zero-dust cleanrooms of Almaz-Antey, extreme ultraviolet lasers precisely etch nanoscale circuits for the gravestone. These microscopic components are bathed in pure liquid gold to maximize electromagnetic conductivity and prevent corrosion. Thousands of these microscopic transmit and receive modules are snapped into a massive, flat, dark gray grid. Unlike legacy radar systems that must physically and slowly rotate a mechanical dish to scan a sector, the gravestone is a phased array system. It emits invisible, high-powered beams of electromagnetic energy that can be steered electronically in fractions of a microsecond. This means the gravestone can aggressively tear through atmospheric interference, track hundreds of targets simultaneously, and guide multiple missiles to different targets at the exact same time. Whether it's a stealth bomber utilizing radar-absorbent materials, a ballistic missile plunging from the stratosphere, or a swarm of localized suicide drones, the gravestone sees everything. Its algorithms strip away electronic countermeasures, jamming attempts, and chaff clouds to reveal the hard, naked truth of the target. It sees you, long before your threat warning receivers even know you are being painted. However, a brilliant mind requires a devastating fist. And this is where the S-400 separates itself from every other air defense system on the global chessboard. Its diverse, highly specialized arsenal of interceptors. While systems like the American Patriot generally rely on a single family of interceptor missiles, the S-400 is designed to fire a mix of different missiles from the exact same launcher, tailoring its response to the specific threat. Let us examine the arsenal. For close-in, highly maneuverable threats, the system utilizes the 9M96E and 9M96E2 series. These are relatively small, highly agile missiles. They do not rely on a massive explosive warhead to destroy a target. Instead, they use a hit-to-kill kinetic vehicle, meaning they physically collide with the incoming missile or aircraft. To achieve the insane maneuverability required to hit a dodging fighter jet, these missiles utilize advanced transverse thrust vectoring. Tiny rocket thrusters around the missile's center of gravity fire in bursts, allowing the missile to snap into high G turns that would instantly kill a human pilot. For the heavy lifting, the system relies on the workhorse, the 48N6 series. Weighing in at nearly 2 tons, these massive interceptors carry a heavy fragmentation warhead designed to shred enemy aircraft and incoming tactical ballistic missiles up to 250 kilometers away. Casting the solid rocket propellant for these massive 48N6 missiles is an incredibly delicate and volatile process, as dangerous as taming a live bomb. A highly explosive, metallic gray chemical dough, rich in aluminum powder and synthetic rubber binders, is extruded into the aerospace-grade titanium casing under immense pressure. Even a microscopic air bubble trapped inside this solid fuel matrix would create an uneven burn, causing a catastrophic internal explosion upon ignition. Therefore, every single fuel core must pass a flawless, high-resolution X-ray diagnostic scan before it is certified for combat. But the crown jewel of the S-400 arsenal is the terrifying 40N6E. This is the extreme ultra-long-range interceptor, boasting an unprecedented operational range of 400 kilometers. The 40N6E changes the fundamental geometry of aerial warfare. It is specifically designed to target high-value assets that normally operate safely behind the front lines, such as AWACS, airborne early warning aircraft, electronic warfare jamming planes, and aerial refueling tankers. By holding these vital support aircraft at risk from 400 kilometers away, the S-400 forces the enemy's entire air operation to be pushed back, effectively creating a massive no-fly zone without even needing to shoot down a single fighter jet. The 40N6E achieves this by flying a unique trajectory. It launches vertically, climbs high into the stratosphere where the air is incredibly thin and friction is minimal, cruises at hypersonic speeds, and then plunges down onto its target from above. Because the curvature of the Earth prevents the ground-based gravestone radar from illuminating targets 400 kilometers away, the 40N6E is equipped with its own active radar seeker head. Once it reaches the target area, the missile turns on its own radar, finds the AWACS, locks on, and executes the kill autonomously. And then comes the most critical moment on the assembly line, the mechanical marriage. A multi-ton block of 4 fully armed missile tubes encasing the lethal 48N6 and 40N6 interceptors is suspended in the air. It is lowered with the delicate precision of a master watchmaker onto the heavy hydraulic cradle of the MZKT 7930 Transporter Erector Launcher, or TEL, This super heavy 8x8 all-terrain chassis is a marvel of Belarusian heavy engineering. Powered by a colossal V12 diesel engine producing over 500 horsepower, the MZKT chassis is designed to carry a payload of 24 tons across the most unforgiving environments on the planet. Massive titanium locking collars slam shut. Heavily shielded data umbilical cables are forcefully connected, linking the missile's internal computers to the truck's firing mainframe. As the encrypted titanium key turns in the ignition, the tactical screens boot up in a cascade of green data. The beast awakens. It is no longer a collection of precision-machined titanium, etched silicon, and solid rocket fuel. It is a fully integrated engine of war. The massive factory blast doors of the Almaz-Antey facility grind open, welcoming the bone-chilling, howling winds of the Siberian winter. For Western weapon systems, these extreme elements, the sub-zero ice, the corrosive salt, the deep mud, are a logistical nightmare. But for the S-400 Triumph, this harsh, unforgiving environment is exactly where it belongs. The colossal V12 diesel-electric engines roar, tearing through the black night, their exhaust instantly vaporizing the falling snow. The mobile air defense battery begins its tactical march into the dark, ready to cast a lethal net of fire across the sky. Deep within the desolate taiga forest, the convoy halts. To understand the strategic value of the S-400, we must look at the global chessboard. Unlike the American MIM-104 Patriot system, which often requires prepared concrete pads or semi-permanent installations to operate at peak efficiency, the S-400 requires no such luxury. It can transform any frozen